Hi. Good morning. Thank you for inviting me to give this talk. I have been, in the past year or so, maybe a little less, sort of dived into the new world of large language models, like a lot of people, I'm sure, to figure out what the hell happened when I was not paying attention, I guess. And I must say that I'm quite sort of surprised, overwhelmed, excited, everything at the same time. I am on the camp that this is indeed a discontinuity. It's definitely something that is going to change a lot of things, a game changer, including in our little world of research in programming languages and in software engineering, for sure. Not to mention just the things that can be done already for software development, the tools that can be done to aid software developers, but it affects also what we do in research and how we think about the problems that we have become accustomed. So the title says it all. I think that, and when I say artificial languages, I mean a broad class of languages that are designed by people, as opposed to natural languages that have been emerged organically among humans. So in artificial languages, I mean programming languages, data structure languages, specification languages, you name it, everything that is on purpose designed by people. And I think that they are dead as we know them. But on the other hand, I think that there's a new era of interesting things that can be done. And basically, artificial languages are not dead. They just are going to reincarnate in something completely different. So that's what I want to talk about. So this concept of programming is the art and science of automating processes, right? We've been doing that since we have computers. And the way that it works is we take some ideas that are fuzzy in somebody's head, and we produce computer processing instructions or specifications. Could be something that is artificially specified. And this process, since computers were invented, has been done by people. There's a person in the middle that takes that idea and writes down in some artificial notation those ideas. And what that produces is artifacts that hopefully are well specified, well formed, that they obey some specification, there's no ambiguity. That's what we want, of course, in practice. We all know that reality is a little bit more interesting than that. But that's the goal, right? We want the artifacts to be totally under our control, and we want to know exactly what is it that the computer is doing with the specification that has been produced. And so these artifacts end up in some form of an artificial language. It could be a programming language, could be SQL, could be JSON, could be any of the many domain-specific languages that are out there. But it's basically something that typically textual, although there are some graphical notations out there too, but this is what we have become accustomed since computers were invented, right? Our generation has grew up looking at problems of this process, right? And all our research questions that we have been looking have been, well, how do you specify this? How do you make sure that this thing on the right doesn't have bugs? How do you make sure that it captures the person's intent? How do you make sure that it, cooperates with interoperates with other pieces like this? All sorts of things. That has been our field, right? But the interesting thing is that can we automate that person in the middle? And can we remove the person out of this loop? But this is not a new question. So the first point that I want to make is that this is not a new question in this age of LLMs. This is a question that has been looked at since the beginning of computers. In fact, since the beginning, we had the spring of programming languages in the 1960s, where compilers were, invented in a way. They were blooming. The need for compilers was very obvious at the time, and compilers are in many ways a way of automating some of what people were doing, right? Translating something that is a higher level to something that is a little bit more low level, that has been replaced. It was made by people, and at some point it has been replaced by a tool. And this continued. In the 80s and 90s, we saw, again, these ideas of eliminating people from the loop popping up in case tools, generative programming, a lot of it coming here from this community, right? Program synthesis, more, it's an old idea, but that has been always there, picking up its head from time to time in different kinds of communities. More recently, efforts like low code or no code, all of that have been approaches to the same question, which is, can we remove the person out of that process? So the question is not new. But however, from playing now with these large language models, it seems that there's something qualitatively different that is happening now. That, yes, things have been sort of progressing about eliminating people from the process, but I think we're going to see something really completely like, that we were not kind of prepared in a way, in many ways. Now, of course, again, we also always have to see these exponentials in context, right? Because that's the way that history goes, right? There's a discontinuity, and then there's things kind of even out. There's a stable period for a while, and then there's another discontinuity, and so it's nothing that hasn't happened before. In fact, in my adulthood as a professional computer scientist, I remember some of these things. Like, for example, I don't remember the invention, and I don't remember the von Neumann computers. I heard about them, but I clearly remember, and so do many of you, the invention of the web in the 90s that felt like one of these. It really felt like that was something that was going to change things. And indeed, it did. It was very rapid adoption. Things started to change all over, like things that people had been talking for at least a decade or more, 2 decades before. People were talking about distributed computing and how to make these kinds of decentralized, interoperable nodes and stuff like that. Had it all been, it's not new, but suddenly the web came out, and it basically fit on something that people were, in a way, predicting that it would occur, but not knowing exactly the form that it would take. And it took the form of the web. It was kind of interesting. And now, I think that large language models are one of these. So in that respect, I want to talk about some of my explorations and some of my students' explorations on this brave new world of LLMs, starting with everybody's entrance to this world, which is chatbots, ChatGPT. But then quickly, if you are a curious person, quickly realizing that ChatGPT is kind of boring and limited, and we want to do a little bit more. So you start lifting the veil, and all sorts of things, interesting things pop up there that make you realize that you can actually develop applications that are powered by LLMs, components that interact with LLMs, and that you can feed things, you can have feedback loops in the process that make things really quite amazing. So in that vein, I'm going to talk about things like prompt engineering, multi-step prompting, semantic retrieval, and all those things that I'm going to sort of explore. So let me start with a live demo, and of course live demos are always dangerous, but I'm going to try. I am going to interact here with ChatGPT. Let me put it here. And of course, in presentation is always a challenge because I see something in that screen that's not here. So hopefully this will work. Hold on. All right, so let me do something here, which this was one of my first experiments with ChatGPT. Well, it was the second experiment with ChatGPT. I wanted to see if ChatGPT really could help me write something that is not trivial. That was my second interaction with it. Hopefully, this will connect. Let's try again. Do I have network here? Hold on, let me just see if I'm connected to the network. I think I am. Okay, here we go. All right, so I wanted to write a tokenizer with ChatGPT, and for many of you, you know tokenizers. They're sort of the first step of any language processors. You have to tokenize the text and produce tokens, and then feed them to the next thing that comes, maybe a parser or something like that. So, I wrote this blog post when I made this experiment, but then I also use it as sort of a script that I can run. So here's what I told it. I don't know if you can read this. Can you read this back there? No? Yes? So I said something, help me write an interpreter for a scripting language. I want to write the interpreter in Python. To start, give me some code for a main function that checks whether there is a command line argument. If so, it reads the file given in the command line and runs it. If there is no command line argument, it goes into interactive mode, prompting the user for lines in that program. Everybody kind of recognizes this little cycle, yeah? So it's sort of the main function. Let me copy this here, and now let me go here into ChatGPT, and I'm just going to do the same thing. All right, so let me do this. Sure, it is. Okay, and it gives me the code, and it starts explaining what the code does. I don't know if you can see. Is it possible to turn off this light over here? Because I have everything in dark mode. There you go. Better. It's better? Yeah. All right, so it gives me a program that it looks like it's doing what I asked it to do. So it checks if there is a command line, an argument. If so, it opens the file and calls, for each line of the file, it calls execute line. Otherwise, it goes into a while loop that asks the user for input, and it executes the line. This seems great, right? This seems good. So what I did from then on is that I would just copy and paste the program that the bot gave me into a Visual Studio and test it. Does this work? And then I went it from there, doing things like, okay, great. So now let's focus on the execute line, right? So one thing that I wanted it to do, so it's a conversation, right? So something like that. Okay, great. Let's work on the run. In that case, it was run code. In my case, it's execute line today. For now, it should scan its input for a sequence of tokens and simply print those tokens out. I just want to know if if there are going to be tokens, and I just want to print them out. So this is an iterative development, right? I don't know how you write programs, but I tend to write programs sort of like, okay, let me sketch sort of the main function over here. Now I'm going to zoom down and zoom in on some function, and it's going to zoom in on some function and zoom in on. So that's sort of the approach that I'm taking here too. So I could do that one more time here live, see what it does out of that tokenization. So let's work on the run. No, it's not run code. It's what's it called? Execute line. Let's work on this function. For now, it should scan the tokens, and okay. So then it zooms in on the execute line. It also suggested some tokens already. I didn't ask it to do it, right? It's already suggested some tokens and how to parse them. I did not specify this, but it just decided to give it to me. Okay, I can work with this. Fine. So I would just copy paste this function to my Visual Studio Code and check that it does something and continue from there. And you can continue, and then I can say, okay, I don't want those patterns, okay? I want some other tokens. Give me some, for example, the next thing is give me a class, give me an enumeration. Here's what I told it. Give me an enumeration of, give me an enumeration that has the following classes of tokens. So single character tokens, 1 or 2 character tokens, literals, and keywords, and the end of the file. Okay, these are my tokens. I'm designing a language. I know what tokens I want, right? So ChatGPT gave me a little language that it thought I wanted, but that's not what I want. I want this language. So I can say, okay, let's try to do this. So I can specify what I want, go back over here. And it gives me actually a lot more than, well, maybe, a lot more than what I asked for. A bunch of keywords that I didn't ask for, but that's fine. Literals, 1 or 2 character tokens, single character tokens, things like that. And so the conversation continued. You can read my blog post. And at the end, I ended up with a program that indeed tokenized according to the tokens that I wanted, and it worked, right? So it was like a programming buddy. It was like a junior assistant. I was asking, I was designing the language. I am designing the language. I am designing the tokens that I want. At points, I actually tell it, look, this is not how I want it. Do it in another way. And it just does it for me. So it's quite remarkable. And at the end, you end up with a program that actually does exactly what I wanted it to do. In fact, the bot at some points corrected me. I was giving it wrong instructions. I was calling some token something bang, and it was not something bang, it was something else, and it corrected me. So that is quite an eye-opener for me, that you could indeed do something. Hold on. Yeah?
They want you to take this off. It's banging on the microphone.
There you go. Okay. Where am I? Okay, all right. I think I lost the control of the PowerPoint presentation. How do I go here, maybe? Okay, all right. Do it again. Okay. So this is probably an experience that many of you may have had when OpenAI came up with ChatGPT. You know, let's try my little pet program, see how it does on something that I know very well. And I mean, I don't know about you, but my reaction is like, holy, you know, this is amazing. What's going on in here, right? But then it quickly, you know, as you start digging deeper, you quickly become aware of it. It's like, you know, it's like my dog, whenever it goes to a new space, the first thing that it goes is figure out the perimeter, right? Where are the boundaries, right? That tends to be what I do too. So where are the boundaries? Where does this fail, and where does this lead me? How does this new world look like? What's the geography in here? So another thing that started coming to focus is that the response of the chatbot depended a lot on the words that I used, like the choice of the specific choice of words, even the sequence of words. The answer would be different depending on what I would ask it. So let me give you just an example over here. And here I'm not going to use the chatbot. I'm going to use the OpenAI platform, for those of you who already also found that, the playground. So here's an example of oops, you're not seeing this. Hold on. Okay. So it's an example of a piece of work that I did with some of my students, which was to find out if GPT could generate commit messages automatically, given just the diffs. Okay, just give it the diffs, no more context, just a diff, and you ask it, generate a commit message for this diff. Okay, and by the way, since you're at it, let's see if you can also provide some sort of justification, which is, you know, in the principles of good commit messages, is that it should say what changed and why, right? It should be a two-part kind of thing. So we experimented with a couple of prompts. So the first prompt that we experimented was something like this. So let me write it here. Generate a commit message for the following diff and provide a justification for the changes. And now I'm going to put a diff in a large diff over here. Doesn't matter. You don't need to understand it. So bang, there's the diff. So notice the words that I use is generate a commit message for the following diff and provide a justification for the changes. So submit. All right, so that seems like a reasonable commit message. Refactoring config settings for token obfuscation and adding support for subtoken creation. Great. And then it goes on to the justification. And it goes on and on and on. And I'm thinking, look, don't lecture me. This seems a little too long. I don't want to have this in the commit message. So how do I make it that it's not so long? Okay, so how do we make it that it's not so long, but it's still meaningful, right? Okay, so we experimented with another prompt. This prompt was almost the same. Generate a commit message summarizing the modifications made in the diff, accompanied by a brief rationale for the change. So we changed the justification to rationale and added the word brief, and also the message, we asked it to summarize the change. So a little bit nudging towards, don't spam me kind of thing. Let me put the diff again. Okay, reorganize token obfuscation settings and added subtokens option to tokenizer. All right, it's a little shorter. It's only one paragraph now of the rationale instead of several paragraphs. That's progress. And maybe I will be able to read this when I'm looking at the project history. It just explains, does it have the, yeah, it has the rationale, right? So in an effort to simplify our configuration and add new features, that sort of feels like rationale. Why did we do this? And why did we add the token section? This setting provides the option to split the tokens on camel case. So there's a little bit of a rationale. So this change at the bottom line, this change will give users more control over their tokenization process. Okay. So we made some sort of a controlled experiment. We took many commits, so lots of diffs. And we had GPT-4, this is also GPT-4, generate commit messages with rationales for, and then we looked at each of them individually to see how well they actually captured the diff, whether it was true or not, whether what the GPT model was saying about the diff was true or not, and whether it was kind of hallucinating, or what were the problems that came from using the model to generate commit message. It turns out that it's pretty amazing, pretty good. It has some problems, but not many. So for the most part, the vast majority of the generated commit messages were actually correct, with good rationales. And the few problems that existed was sometimes it says a lot of truisms, like stuff like this. You can see already, this change will give users more control over their tokenization process. Okay, you could avoid that sentence. It's not necessary, for us, right? And this is not so bad. There are other truisms that are totally redundant. You shouldn't say that. So it's a little harder to control those truisms. But for the most part, it actually did pretty good at capturing the essence of the diff. And the other interesting thing is that we then compared to the original commit messages by the developers. And you're not going to believe what happened next. These messages were actually better for the vast majority of the commits. And it's not that, a part of the reason why they were better is that because the original commit messages are really bad. As you probably know, who hasn't written that awful commit message like update something, minor tweaks, or something like that. Like, it doesn't say, we know that we should be descriptive of what happened, we just don't have the time. So because a lot of commit messages are bad, a lot of the original commit messages are bad, actually these kinds of explanations and rationales end up being actually better than the original. So that is quite amazing. But the point why I'm making this, the main reason why I'm showing this piece of work is to convey the message that the words that we use, what we ask the model to do, matter a lot. Every single word matters a lot. So now it's become a really weird engineering situation, which is what words do you use and why? How do you justify the words that you use when you're doing some research, for example, and you find out, I'm going to ask the model to do this, so I'm going to just blurt what comes into my mind. No, you have to justify why did you choose those words? And what words did you try? And what happened when you try different words? Right? It's an interesting thing that has become apparent, at least for research and for reproducibility and understandability of things, like why these words and not other words. So this is one interesting thing. Another interesting thing that happened. This goes into the idea of what has become known out there as prompt engineering. You probably have heard this term. This started, 2 years ago with like prompt hacking, right? You just switch words or put some like code words in the prompt, and then you figure out if the model responds better or not. But it has become more of a systematic practice, and now it has the term prompt engineering. These are methods to steer the model's behavior for desired outcomes without updating the model's weight. So the model is fixed, right? It has been trained. We're not changing the weights, but we want the model to behave in a certain way. We want to steer it so that it produces a certain outcome all the time, rather than something that we don't control, right? So every word matters. The other thing that started to become apparent to me is that while these models do pretty good with the programming languages for which there is a lot of data out there, like Java, C++, Python, it's fantastic. There's clearly limitations when you start wanting it to generate programs in languages that it hasn't seen a lot. And that's where things become really interesting. So we were looking at another study in my group, which is to, okay, this is the automatic commit message. Yes. Which is the Daphne. So Daphne, you may know, it's a programming language, functional object-oriented imperative programming language designed by Microsoft Research that has formal verification, and works with a theorem prover on the back end. And so you can write provably correct functions, they call it methods, in Daphne. So you write imperative code, and then intermingled in the imperative code, there are formal specifications and then proof annotations that help the verifier prove or not what is it that the formal specifications does. Needless to say that these models have not seen a lot of Daphne. In fact, when we went to GitHub, we found only about 200 or so Daphne projects, which is close to nothing, right? So there's not a lot of Daphne code out there. So if you, but nevertheless, it tries, and it gets some things right? So let me show you here. Let me get rid of this. Let me show you an example. So we started asking it to generate some things in Daphne. So here's a prompt. Write a method in Daphne to find squares of individual elements in an array. No more context, just what we want. Okay, just saying, give me Daphne code. Okay, so it tries, and it surprisingly knows quite a bit. It knows that the functions are called methods. These imperative functions are called methods. It knows that it has these annotations. I'm going to let it finish. Okay. It knows that it it hasn't finished. Okay. And now it always likes to tell us, to lecture us what is it that's happening here. Okay, stop. All right, thank you. So it knows about these pre and post conditions. It knows about hopefully the type system, right? It knows what types there are in Daphne. It knows quite a bit, considering that's not a lot of Daphne out there. It surprisingly does not completely mess up. But of course, we can try and then go, copy paste this into a Visual Studio. Sorry. Let me try to do this and put it into Visual Studio here. Let me put my Visual Studio here. Oh, actually, you know what? It actually verified. It's quite amazing. For those of you who don't know Daphne, you put it in the Visual Studio, and if this line is green, if you see this green line, it's because it's verified. Okay? So it actually, amazingly, it verified, right? It has the post conditions, and it's a strong post condition. It ensures that everything in the output is the square of the input. And it has all the invariants and everything. It actually got it right. Okay? But this is a relatively simple problem. So let's try it another problem over here. So let's go here and give it something that's a little bit more complex. Okay, something like this. Write a method in Daphne to remove characters from the first string which are present in the second string. That's a little bit more complicated. So it really loves lecturing, that's for sure. Okay, you're already seeing, for example, that this one, it doesn't even try to give us the formal specification. I'll go back and tell you after it finishes lecturing us. All right, so let's see what happened over here. So it gave us a method indeed, a method remove characters from, two sequences over here and returns another sequence. But as you can see, there's no pre or post conditions. And without post conditions, this is basically a trivially verified. It verifies because there's nothing to verify. So that is not ideal. Let's put it this way. Yes, this may even actually be correct. I don't know. Maybe the syntax may be correct. Let's try. Yeah, okay. The syntax is actually correct, which is amazing. And it's green, but it's green because there's nothing to verify. And that defeats the purpose. So we want it to write Daphne code. We want the pre and post conditions, right? And then the proofs that is actually correct. So this is interesting, right? Because you quickly start realizing, okay, so it knows a little bit about Daphne, but it doesn't know enough. And maybe it knows enough to give us the verified programs for very, very trivial problems, but for things that are less trivial, it just doesn't even try to write those formal specifications, right? And that's not what we want. So the question is, so at this point we have two attitudes. You say, okay, this sucks. Okay, forget it. We cannot use LLMs for anything other than Python and Java. And there's nothing here for more interesting things like Daphne or other languages that we are all developing over here. Unless there's a gigantic database out there of examples, then these models don't know anything about it. So you give up. And you say, okay, haha, great. I still have something to do because the LLM doesn't know my little niche language. But that's not the attitude that we took. The attitude that we took is that you can teach a pre-trained model after it has been trained. It's a very important thing to keep in mind. What the LLMs tell you after a very naive prompt is just the beginning of what it can do. Okay? Again, it goes back to the prompt. The prompt that you give it has a lot of influence on what it's going to give you back. So the question is, so how can we teach the model that clearly does not enough about Daphne? How can we teach it Daphne without pre-training it again, or finding a gigantic database of Daphne programs and doing fine-tunings, because these models can also be fine-tuned, but it requires a lot of data. How can we do it if we don't have a lot of data? So we can do it, in fact. So here's what, it's the topic of a paper that's under submission, but I'll just give you a little overview of the approach. So what we do is the following. We have a small database of Daphne, verified Daphne programs that we wrote by hand. We have about 50 of them. Algorithms of these kinds, right? So we wrote them, there's 50 of them. And now for every single new algorithm that we want the model to generate a verified program for, we do the following thing. We do something a lot more complex than what I've been showing you so far. So the first thing that we do is we take it step by step. So first thing that we do is say, okay, write in natural language, okay, in English, write down what are the preconditions and postconditions for this problem. Okay, given this problem, whatever this one for remove chars from one sequence that are given in another sequence, write in English the pre and post conditions. By the way, what I'm going to explain is very similar to how you would guide students, for example, how to solve these problems, right? So that's the first step. Now, once you have the pre and post conditions written down by the model, you want it to generate the code. But how are you going to have it generate the code? So here's what we're going to do. We're going to look into our database, small database of 50 examples, and we're going to find the 5 most similar programs to the new task that we are asking it to do. Okay? And what we define most similar, by we match the post conditions, because the post conditions are the most important things in here. So we match the similarity of the post conditions, and we find the 5 most similar examples in our database. And then we construct a second prompt that has, okay, and I don't have time to explain the whole thing, but here are the 5 examples. And now do the new thing that we're asking you to do. And believe it or not, we were able to get the model prompted in this way to generate another, forget the exact number, but it was like 100 or so verified algorithms on the, totally correct, with the right post conditions, strong post conditions, with the right annotations that the verifier could verify everything. Okay, so it's not as, the first reaction is saying, okay, so this cannot know Daphne, great, I'm going to give up, I'm not even trying. That's not the right reaction. The right reaction is, okay, how am I going to teach it what I want? And interestingly enough, the teaching has a lot to do with how we teach students. That's the bizarre thing. It's really weird. The way that we teach students with lots of examples, meaningful examples, right? With teaching them to divide things step by step, that also works here. So it's quite amazing. So let me move on because I'm getting. So what we ended up doing was this. I don't even know how to call it. We multi-step dynamic few-shot prompting with chain of thought. It's a combination of techniques that have been sort of published in the machine learning world of how to prompt these models so that you can get more out of them, that they actually didn't have enough data to start with. All right, so just calls to the important thing to note is that there's the raw API calls, one API call, one prompt of the model, but then there's all sorts of things that you can do around it, right? You can design an entire application that goes many times with different kinds of prompts, do this now, and then based on that, do that other thing now, and maybe now you also have a semantic database, a vector database, that you find similar things from there, and you retrieve them, which is what we did for the examples, and you add that in the prompt. There's all sorts of interesting, fantastic new worlds in here to have these very rich applications that take the most out of the models. It's not just what the model knows out of the box. So can we automate this? I think we can. Yes, we can. And we have been automating this, for many decades. But now we can really really kick it. The last part of actually using sort of natural language to create programs. But there are some caveats. So let me talk first about the yes, you can. So the models know a lot already, as we saw in Java and Python and all that stuff. We don't need to teach it, already knows a lot. But they can learn. They can learn even more if you teach them appropriately. In particular, the examples work really, really well. And chain of thought and stuff like that, dividing things by steps. So yes, we can do a lot. So for popular languages, in spite of the models knowing a lot, you cannot trust blindly, of course. You have to check it, review it for accuracy, you have to test it. You cannot just take the model at its face value. For niche languages, simple prompting is not enough. So maybe you have a large database of examples you can fine-tune. If you don't, then you can do all sorts of combinations of techniques from machine learning that you can take the most out of the model by teaching it in the prompt itself. All right, so let me kind of get to the end of the talk. The queen is dead, and I looked at I don't think you can read it, it's a little fuzzy, but I looked at the topics of interest of SLE, this conference. And I see things like software language design and implementation, approaches to and methods for language design, static semantics, techniques for specifying behavior, generative approaches, meta-languages, etc. So it's a long list of topics over here. I think a lot of these topics are, the traditional classical approaches that we have been kind of gently improving over the years are probably dead, because you can get a lot out of these models for actually helping you give solutions for whatever problems you are looking at. In fact, the whole thing about designing artificial languages may be put into question, right? Why are you going to design yet another language when you can actually have the people talk in natural language and then have some AI transform that to JSON or whatever? Right, so the whole thing may be put into question. So you kind of have to go through all of these things and kind of question, okay, so what's happening in this particular topic, given that these models are so powerful? So these are all questions that we as communities need to do. There is a discontinuity, and there's a danger that we are kind of stuck in the old ways and sort of miss the train because the train has arrived. On the other hand, I think that it's a very exciting time because, it just turns out that the problems are still there. They just take a slightly different form. So, yes, what I just said, like, why are you designing new languages anyway? Because you can talk in natural language. Well, that's actually not true, as I showed you here. The words that you use matter a lot. So if you give a UI to some person and you let that person just use whatever words they want to use, chances are that that's just not going to work. And now what? Now we're back into the mode that we actually need to inject something artificial, right? We need to process the words that the user inputted or something. Right? And we're back again to have to design something because, if you just let people just talk naturally as if they're talking to a person, that only works in very specific situations. So I think there's a lot of excitement in here. There's lots of interesting things in here. In all of these topics, again, you just need to look at them in a slightly different glasses, with different glasses for sure. So my very last message is that programming and the things that we do, it has always been and it will always be about effective communication, which of course is related to language. And effective communication is things that, yes, it includes notations, artificial notations, But it's not just that, right? This is a problem that exists, well beyond computer science. So people, when you have legislators that write the laws, there's an art to writing laws so that it doesn't become a total mess, right? This is why you call it codes, to some extent, or any kind of specification. Building codes, for example. There's an art and something similar that you have to be very precise. You have to communicate the intent really, really well. And of course, we in computer science have been used to doing that in super artificial languages that have an automated, an executable semantics, and that is even connected to mathematics that can connect directly to theorem proving and all that stuff. We've been using to doing that. But I mean, the whole point is that it's about effective communication, that whatever the intent is needs to be communicated properly and unambiguously, and that can be done with super artificial languages. It can also be done with slightly less artificial languages, and there's a spectrum in here. And I think these language models now allow us to explore a lot of this spectrum over here. It's an interesting thing that is, I think, is happening. So with that last message, I thank you, and I can answer some questions. Thank you.
Thank you very much, Crista. Very entertaining and stimulating. I'm sure it will generate lots of questions, but we've only got a few minutes, so.
The question over there.
Thank you for the talk. I wanted to react to really the last point you made on the need for communication, because I very much agree with that. I, however, respectfully disagree with the point you were making that current LLMs actually support that. We as language engineers, we tend to, a lot of times, focus on the language. The language is just a means for communication. It isn't the thinking. It isn't really programming. It isn't the part in the middle. And when we look at dealing with simple programs like this, we miss that the real job is, for instance, something I actually worked on is how do you come up with a common model in an SOA architecture to federate 3 loan origination databases so you can run 5 billion transactions a year through it. To get from that statement, which was an English statement, to something actually running required multiple levels of analysis and design, which were not easily done in natural language, which required multiple artificial languages, modeling languages, representation languages, which we created and have created not just in computer science, but over 2,000 years, to do things natural language isn't good at. What I'm wondering is we have this powerful capability to do language machine learning now. Instead, we are focusing on the surface representation of large language models and how to, I would say, hack prompts in what is not a good way to communicate precisely, rather than, and you literally said, don't train the model, you can do it with the prompts. Well, why aren't we focusing on training the models with the kind of specialized domain data we need to handle large problems, rather than taking what are trained by somebody else to do other things and then trying to force them, like we would a person, into doing what we want?
Oh, I mean, so I think there are many points that you are making. The first, let me try to re-say what you said. So the first point is about that this is not just about little programs, it's about building systems and having sort of a shared understanding and a model of what's going on, and being able to understand systems at a larger scale. I completely agree with you. The other point that you are making, that you made also to the second part of what you were saying, is that there's these 2 ways of doing machine learning. One is to train models for specific problems with data that is specific to the problem. Another one is the large language model route, which is basically has been trained to understand natural language And then from then on is able to reason and solve problems with reasoning. That is sort of and you know, I don't know, these are two different ways of going. The large language models, as far as I can tell, have been blowing the other more specific ones out of the water. Also because they have the capability to have fine-tuning. So if you have a data set that you really care about and you want to have things for that particular data set, you can fine-tune on top of this basically reasoning engine or language engine that is already pre-trained, right? And the other ones don't have that. So the other ones have only your data. So they are immediately more limited than the large language models. But you know what you were saying, I think that it relates sort of with this slide that I had hidden in the presentation. There's all things related to software construction. And I was talking just about the part of programming in a way. So, you know, getting somebody's fuzzy specification and putting it in square boxes. And there's lots of other things around. And I didn't, although I didn't focus on all those other things, my belief is that there are not the chatbot interface. Again, the chatbot interface is really misleading. I hope that's a point that I've been making here, that you understand. Chatbot interface is super misleading. There is, however, an opportunity for us and people working in this area to do applications that use LLMs for specific purposes. Right? You don't put the chatbot interfacing directly with a person. What you do is you put the person, you decide what is the input of that person, and then you put some intelligent process under your control. Under your control, that's the important thing. That is repeatable and it always behaves the way that you expect it to behave. So it's a little bit, it's more like programming in a way, right? But you're using the reasoning capabilities of this language model. So that's, I think, what I was trying to say.
Thank you. Perhaps if anybody's got a quick question, so we don't eat into the next. Okay, well, obviously a topic for great discussion. Thank you very much, Chris.
All right, thank you.